All right, today we are continuing lesson 1-5, parent functions and transformations. I don't know why my screen is glitching like this. It's a little glitchy. Wow. Settle down, screen.
Like when you put it in the testing, and you're rewinding it.
Exactly. Oh, hey. All right. Anyways, so what I want you guys to do, go to your graphing calculators. All right, hit second x squared. We're going to say x, so the square root of x, and hit the graph button. All right. So here we have y equals the square root of x. Y equals the square root of x. Now, if we go back and look at this one right here, what should I do? I should take my y values and make them negative. So if you want to see this green graph right here, what you would do, okay, you would go to your graphing calculator, hit y equals. Let's go down to y5. Okay, and type in negative square root of x and hit graph. And look what happens. So what do you have? You have a reflection over what? There's a reflection happening over the x-axis. So anytime you have a function, if this is y equals f of x, if you wanted to reflect it across the x-axis, all you have to do is take whatever that function is and just make it negative f of x. Okay, you don't have to put parentheses there. But negative f of x, and that will reflect across the x-axis. All right, let's go back to our. Now, how do we make this happen? So here's our original function. There's y equals f of x. How do we make y equals f of negative x? Here's what you do. You go to your graphing calculator. Hit y equals. Let's go down here. Clear this guy out. Let's go up to red. We're going to hit second x squared. And in parentheses, I'm going to say, I always want my x's to be the negative version of themselves. All right, the opposite. And watch what happens when I hit graph. What? Cool. That's awesome. All right. And what does this reflect across, everybody? Oops, that's not very good. The y-axis, right? Nice. So, everybody, in your journal, you should have y equals f of x. And over here, you're going to say y equals f of negative x. So here, what happens? We make all of our x values negative. X values negative. And what happens? You reflect everything across the y-axis. Okay? So if the y values are negative, it reflects across the x-axis. If the x values are negative, it reflects across the y-axis. Right. So far, so good? No? You got it? Okay. All right. Let's continue on without talking. Let's see what happens. How about this? Let's look at this quick little example. Tell me what looks like happened from here to here. What do you think happened? Translated up. How many? 1. So what would my equation be? What would g of x equal? We have our original function, the square root of x, and what are we going to do? We're just going to add, not subtract, but add 1, right? And that should move this sucker up 1 unit. Let's see. Okay, there it is, the square root of x plus 1. Very good. Ooh, 2 things happened in this graph. Tell me, what 2 things do you think happened in this graph? What's one of them that you think? What's the easiest one to recognize that happened? Yeah, so we have what? We have a reflection, right? Now, if it was perfectly reflected, we would have one that goes down like that, right? So it reflected, but what else happened to this? It slid over what? 1 unit to the left. So, g of x, okay, equals the square root. Now, what we're going to do is we have to do what? Reflect this across the x-axis. So we got to make this not positive. We got to make this negative. And it slid over 1 unit to the left, so we have to say x plus 1. Now, why do we have to say x plus 1? Because what number plus 1 gets us back to 0? Negative 1. That's why we have to say x plus 1 and not x minus 1. So our graph should be this. Oh, let's check it in our graphing calculator first. Let's check it. Let's see here. So we're going to hit y equals. I'm going to go down to this one right here. I'm going to clear it out. Hit negative square root of x plus 1. Now, if you have access to a graphing calculator, you can actually test your theory, see if it works. Did it reflect and slide over 1 unit? It did. All right, cool. So we were correct. Negative x plus 1. All right. So right now, I want you guys to look at this carefully. All right. I'm going to pause the video, let you read it, and I want to see what you guys come up with. All right. So look at this graph. There's the original graph. Here's the new graph. See if you can figure out what happened. All right, what did you all come up with here? What do you think the answer is?
B.
B. Let's see if you're right. You're right. It is B because it did translate down 1, 2, and 3 units. So right here, you can clearly see it went from here down 3 units. Good job. All right. Ooh. Next part right here, everybody. You guys need to put this in your journal. We're dealing with vertical and horizontal translation. Right now, this is not translation. This is dilations. Hey, look, there's a typo. Whoever made this is not dealing with translations. This is dealing with dilation. It's a transformation. It's a transformation known as a dilation. Yes, you need to put this in your journal. Right now, if you're watching the video, I would pause it and then write it down. All right, what we're going to do right now is we're going to talk about the difference between expanding something vertically and compressing something vertically. Now, right here, it's kind of hard to see, but if it says if your A value is greater than 1, it's going to expand this graph vertically. So we're going to do that. I want you guys to write g of x equals, you're going to put 2x squared. This 2 represents your A value. So once you've written that down, go to your graphing calculator. All right, hit y equals, we're going to clear this out. We're going to clear this out. We're going to start with x squared. This is our parent function, okay? X squared is your parent function. Now go down to y5 where it's green. And I want you to type in 2x squared and hit graph. And I want you to notice that this graph, all right, this is considered to be expanded vertically. It's expanding vertically because it's getting closer to the y-axis. So anything that's expanded vertically gets closer to the y-axis. We'll put y equals 2x squared. Remember, the 2 represents your A value. If your A value is greater than 1, it's going to expand vertically. That's the first dilation that we're talking about. All right, the next dilation we're talking about right here, this is where things are being compressed vertically. All right, so if things are being compressed vertically, that means your A value, okay, your A value is going to be between a 1 and a 0. So less than 1, but greater than 0. So right now what I want you to do is I want you to say g of x, the red graph, is going to equal a half of x squared. Because right now I'm saying, what is my A value in this particular case? I'm saying it's equal to a half. All right, so that's what I'm going to do next in my graphing calculator. I'm going to go to my graphing calculator. I'm going to hit y equals. I'm going to go down. I'm going to clear out this y5 so that you guys don't focus on this one. I'm going to go up to y2. And this time I'm going to do 1 divided by 2, which is my A value, x squared. I'm going to hit graph. And I want you to notice that this graph is considered to be compressed vertically. Now, when you think of the word vertically, I want you to think of the y-axis. Okay? Didn't talk about that earlier. So, when you think of vertically, think of where is it going? Is it either going towards the y-axis or away from? So this one is doing what? This one's not going towards the y-axis. This is being what? Pushed away from, like you're compressing it away from the y-axis. And so what does your a value have to be between? It has to be between a 1 and a 0. Okay? So if I wanted to compress this further away from the y-axis, what fraction could I put in front of it instead of a half if I wanted to go further away? What do you think? Instead of a half. Throw out a fraction less than a half. A third, a fourth, okay. 7. Yeah, that goes further away. Right? Okay? Well, you're right. If I want to go even further away, I could say a 7th, or I could even say an 8th. Right? That's going to go even further away. It's going to be compressed further and further away from the what? From the y-axis. Alright, so, in review, we have vertical dilations known as what? You're either expanding them vertically or compressing them vertically. Alright, now, let's go back to this right here. Now we're going to be talking about horizontal dilations. Now, horizontal dilations either go towards or away from the x-axis. So this one, would you guys agree this graph and this graph look very similar? Those green graphs look very similar. But the function's different. Watch, I'm going to put g, I'm going to change to green. G of x equals, now watch, I'm going to put parentheses 2 x squared. So I want you guys to notice that right here, this graph right here, I am putting the number that I'm going to be putting next to the x, not outside of the parentheses, all right, but actually inside of it, okay? So right here, this says what? This says g of x equals parentheses a x. So where's the a value? It's not on the outside, like this one. This is a times f of x right here. This is right next to the x. So watch it, look at the difference on this one when we put it in the graphing calculator. Hit y equals. Clear this out. Let's go to this one right here. I want you to go parentheses 2 x, close parentheses, squared. And look how much that changes the graph. Do you see how this one is different than the first time we did it? Now, this one is actually, we call this something. This is not being expanded vertically. All right? We call this what? Compressed horizontally. Now, that's kind of confusing to start out, so let me explain why. I want you to know, we are going away from the x-axis. So anytime you compress something, you're going away from the axis. Do you see how right now, if I made a perfect green line going across, and I started bending it, imagine me bending this line where it starts to curve. You're compressing it away from the x-axis. So we're going to say, ready? Compressed horizontally. Okay? This is being compressed horizontally because it's my a value is what? It's greater than a 1. And where are we going away from? Horizontally means you're going away from the what? From the x-axis. So the vertical was what? The vertical, let me go back over here. Oh, if you compress something vertically, you're going away from the y-axis. If you compress something horizontally, you're going away from the x-axis. And remember, what was this function? This was g of x equals parentheses 2x squared. All right, final one. This one right here. This is expanding it horizontally. Expanding means you're going not away from the x-axis, you're going towards the x-axis. So expanded horizontally means you're going towards the x-axis. I'll take a picture of this right here. So if our original function right here is f of x equals x squared, if we wanted to make it go towards the x-axis, we're going to say g of x equals parentheses a half of x squared. And what's my a value right here? My a value is a half. So right now we're saying g of x equals f of a times x, which is different than this one. This one is g of x equals a times f of x. Notice the a is here on the outside, here the a is on the inside of the parentheses right next to the x. So this is how you would write it. So I'm going to type this in the graphing calculator. We'll take a look. So y equals, go down here, clear this out. I'm going to do 1 divided by 2 x squared. Oh, sorry. My bad. I need to put parentheses there. There we go. All right. So a half of x, and then I'm squaring the whole thing. Now when we hit graph, look how wide this one is. Okay. So what's happening with this graph? This is called what? Expanding. Expanding horizontally. All right. So where are we going? We're going which direction? We're going not away from. We're going towards the x-axis. All right. We're getting closer and closer and closer to it. So our a value is going to be between what? It's going to be between a 1 and a 0. That's if you wanted to expand it horizontally. So if we want to make it expand even more horizontally, what could I do with this fraction? I could change it from a half to a what? Watch this. Change it to 8. Look how close it gets to the x-axis when I do that. If I do a 10th, actually if I do a, let's say watch, if I do a 20th, it'll actually probably almost look like a perfectly flat line, even though technically it's not. If I do 1/20th x squared, like that, watch. It almost looks perfectly flat, even though technically it isn't, all right? If I wanted to change my window, I could go from what? Negative 100 to positive 100, then you might be able to see the curve. We'll change it to 10. Why does this one look so skinny? Because I changed my what? Changed my window. Now you can actually see the what? You can actually see the curve of that. Before, when I hit zoom, zoom 4, you can't see that curve. All right? All right, so let me go back to our notes real quick. So, in summation, we have vertical dilations and we have horizontal dilations. The vertical dilations, the number is on the outside of the function. The horizontal dilations, it's right there in the parentheses. That a value is right there next to the x. Okay? So you need to know the difference between those four different dilations. All right, and that's it.